Hello, today we are going to be looking at Learning Target 3 from Unit 7, which is I can use transformations to prove theorems about lines and angles. And we're going to be looking at the angle relationships that are formed with parallel lines when we have a line that cuts through that. I'm sorry, I didn't realize my screen just shifted. All right, so a line that crosses parallel lines to create pairs of congruent and supplementary angles is known as a transversal. So you'll hear me refer to parallel lines cut by a transversal, and that's what I'm talking about. If you look at the picture that we'll be looking at below, you see your parallel lines and then the line that is intersecting those two parallel lines. Another vocabulary word that we're going to be talking about is the word that has the definition having the same measurement, which we have been talking about a lot this unit, which is congruent. And then angles that add up to 180, that should be review, that is supplementary. So if we have angles that add up to 180, those are considered supplementary angles. Okay, so angle pairs and parallel lines cut by a transversal. So it's important that we understand location because part of the names of our angle relationships are going to include kind of the location that we find them. So you'll notice that we have two angles right here. Those are both outside the parallel lines, so we would call those exterior angles. We also have some below the parallel lines that are also exterior. And then between the parallel lines, that's where your interior angles are going to be. And so those are the four that we'll be talking about in regard to interior angles. So what are the different angle relationships that we have? Our first one are angles that lie on the same side of the transversal and on the same side of the parallel lines. These angles are in the same corner and are congruent. So we would call those corresponding angles. And how we locate corresponding angles, so if I were to choose this angle right here, that exterior angle above the parallel lines, if I were to translate that angle down to the next parallel line, it would be right there. So since I can get those two angles, I can prove those two angles are congruent by a transformation of a translation. That's how, well, the translation is what allows us to know that it's congruent because translation is a rigid motion. Now, those are not the only sets of corresponding angles. I could have taken an outside angle, the other exterior angle, and translated it down to there. So those two angles are also congruent. If I chose this lower interior angle and I translated that down, it would map to this exterior angle below the parallel lines. And last but not least, I could find that last angle that we haven't addressed, translate it down, and I can find the congruent angle there. Okay, so within a set of parallel lines cut by a transversal, you can get 4 sets of corresponding angles. Our next angle relationship are angles on opposite sides of the transversal and are inside the two parallel lines. Okay, so the key words here are opposite and inside. So we would call these alternate interior angles. So the alternate corresponds to opposite sides of the transversal, and then clearly interior corresponds to inside. So if I were to look at only the interior angles. I have this angle here, and if I am looking for another inside angle that is on the opposite side of the transversal, that would be this angle here. Now, those cannot be congruent by a translation because you'll notice that I didn't just slide it. I had to turn it to be able to get them to map to each other. So alternate interior angles are actually congruent by rotation. And then we can see that there is the other set of interior angles. I have this angle right here, and if I were to rotate that to the other side of the transversal, it would map right there. Okay, we also have angles on opposite sides of the transversal and outside the parallel lines. So opposite we know correlates to the word alternate, and if it's outside, we know we call those exterior. So these are going to be alternate exterior angles. And those are also congruent by rotation. So if I have my angle there, if I were to rotate that, it would map to that angle, or if I took my obtuse exterior angle and rotate it, it would map to the lower exterior obtuse angle. Again, on opposite sides of the transversal, outside the parallel lines. Our next example, we have angles on the same side of a transversal and inside the parallel lines. So these actually usually have, or these can actually have two names, same side and then inside. So sometimes these are referred to as same side interior angles. However, you will sometimes hear them referred to as consecutive interior angles. These both mean the same thing. Okay, so if I'm looking for same side interior angles, if I take this obtuse interior angle here and the other same side interior angle, we can already see that those are not going to be congruent because there's no transformation that would map one to the other. We can also very clearly see that one is obtuse and one is acute. So it's important to understand or to remember with consecutive interior angles, they are supplementary, which means that they add to 180 degrees. Okay, and then we can also look at the other set of consecutive interior angles, which would be right there. Okay. Angles on the same side of the transversal and outside the parallel lines, I think by inferring or using our inferencing skills, we can recognize that this is going to be relatively similar to the previous one, either same side exterior angles or consecutive exterior angles. All right, and that would be looking at those outside angles that are on the same side of the transversal. And again, they are not congruent, they are supplementary. Okay. All right, let's put this together. Okay, so our last type of angle that we're going to talk about, our angle relationship, are angles that are across from each other and are formed by intersecting lines. These intersecting lines do not have to be parallel lines and transversals, and the angles are congruent. So if we have angles that are across from each other, those angles are going to share a common vertex, and so we would call those vertical angles. And vertical angles are congruent by rotation, because we could rotate it about that fixed point, which we've talked about as our center of rotation. And we can see that just as we did with our corresponding, we have about 4 sets of vertical angles. And last but not least, right there. Okay, so why do these angle relationships matter? So we use these angle relationships to allow us to solve types of problems when it comes to the relationships formed. So for example 1, it says for each set of angles, name the angle pair and find the missing measure. So looking at number 1, I can see that I have one angle, it's an interior angle, and then my angle that I am looking for is an exterior angle. And if I were to transform 68 degrees to map onto x degrees, I can see that that's going to be a slide down, which would be a translation transformation, which the only angle relationship that is congruent by translation is corresponding. So it is a corresponding angle relationship. We know that corresponding angles are congruent. So if they're congruent, that means that x is going to be equal to 68 degrees. Looking at number 2, the type of angle relationship, I can see that they are on the same side of the transversal, and I can also see that they are definitely not congruent. There is no transformation that would make them the same. So these are going to be supplementary angles, or they're going to be supplemental to each other. Okay, and the angle relationship, since they're both inside, they're on the same side of the transversal, which is consecutive, and then they're inside, so that would be interior. And since consecutive interior angles are supplementary, to find the value of x, I'm going to take 180 and subtract 134, which gives me 46 degrees. Okay, go ahead. I want you to do these last 2 questions in example 1. Pause it and then come back and check your work. Okay, so hopefully for the third example, or the third part of example 1, you got that those were consecutive exterior angles, which means that they are supplementary. So you would have had to do 180, take away 77 degrees, and you would have gotten that x equals 103 degrees. And then on the last part of example 1, those angles are on opposite sides of the transversal inside the parallel lines, which would make them alternate interior angles. We know that alternate interior angles are congruent by rotation. And since they are congruent, that means that x is equal to 106. If you didn't understand that, go back and look up at the notes and try to work through that. If you still have questions, obviously come join my office hours at between 12:30 and 1:30. If you can't make those times, email me. We can always set up an extra time that you could stop by and get your questions answered. All right, example 2. For each set of angles, name the angle pair, write the equation, solve the equation for x, and plug in x to find the missing angle measures. So lots of different pieces to this, however, they all kind of flow together. So looking at number 1, the type of angle pair, I notice that they're on the same side of the transversal, so that would make them consecutive, and they are inside those parallel lines, so that would be consecutive interior angles. We know that consecutive interior angles are supplementary meaning they add to 180 degrees. So if I take one angle, which is 3x, and I add the second angle, which is 6x, if they are supplementary, they have to add up to 180. So 3x plus 6x equals 180. 3 plus 6, 3x plus 6x is 9x equals 180. Divide both sides by 9. We get that x is equal to 20. So x is equal to 20. And that is not it, though, because 20 is not the angle measure. So I would look at 3x as one of my angles. 3 times 20 is 60 degrees, and 6 times 20 is 120 degrees. So these two angles are 60 degrees and 120 degrees. Okay. My second example, name the type of angle pair. I see these are on opposite sides of the transversal, so that would make them alternate. And then they are outside the parallel lines, so that would be exterior angles, alternate exterior angles. Alternate exterior angles are congruent by rotation. So if they are congruent, that means that whatever the measure of 7x minus 12 is, that's going to be the same as 3x plus 28. So my equation would set those equal to each other. And then we would solve. So 7x minus 12 equals 3x plus 28. If I add 12 to both sides, and I subtract 3x from both sides, and that gives me 4x is equal to 40, which leaves me with a value of x equals 10. But again, that does not mean that I am done. I then need to plug that 10 into my equations. So 7 times 10 is 70. Take away 12 would be 58. And since we know they are congruent, that means both angles are going to be 58. Okay, so that's all for the notes. Make sure you submit these in Google Classroom so you get credit for completing them, and then go on to Delta Math to complete your assignment there. Okay, if you have any questions, email me or sign on during my office hours. Do be aware I sent a link out today. The office hours have changed, so the Zoom number has changed, so make sure that you get the correct link so that if you do need to talk to me, you're able to actually access me and not going to the expired link. So I hope everything is going well. You do have a quiz covering everything we've learned so far on Thursday. I attached the study guide to your Tuesday assignment, so make sure that you are completing that so that you can turn that in and then take your quiz, and you'll be taking your quiz through Otis on Thursday. But I will talk more about that tomorrow in Google Classroom. All right, good luck. Talk to you later. Bye.